We now discuss the solution of a problem from the section complex numbers and quadratic equations. And this question is related to a circle and an ellipse. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is the number of points of intersection of mod of z minus in brackets 4 plus 3i is equal to 2 and mod z plus mod z minus 4 is equal to 6, where z belongs to the set of all complex numbers is. We are given four options. Option A 0, option B 1, option C 2, option D 3. So we are given modulus of z minus 4 plus 3i is equal to 2 and mod z plus mod of z minus 4 is equal to 6, where z belongs to the complex plane, and required to find the number of points of intersection of these two curves. We now discuss the solution of the problem in detail. We are given modulus of z minus in brackets 4 plus 3i is equal to 2. Recall, modulus of z minus z1 is equal to r, where r is greater than 0, represents a circle with the center at z1 and a radius r. The radius r. Now this represents a circle with the center at 4 plus 3i in the complex plane and the radius 2. It is a circle with the center at 4 plus 3i and a radius 2. We are also given this curve, given mod z plus mod of z minus 4 is equal to 6. Let's call this as the equation 1. And what is this curve? What is the locus of z in the complex plane? Let us recall the equation mod of z minus z1 plus mod of z minus z2 is equal to k. This describes an ellipse with foci at z1 and z2 if k is greater than the distance between z1 and z2, that is mod of z1 minus z2. If it is so, then what is this given curve 1? Now, here k is equal to 6, z1 is equal to 0, z2 is equal to 4. You notice that 6 is greater than mod of z1 0 minus z2 minus 4. That is 6 greater than 4. Yeah, it is correct. So, it represents an ellipse E with foci at 0, complex number 0, that means the origin 0, 0, and at a point A 4, 0. So these are the foci of this ellipse. Agreed. Now notice now the center of the circle is 4 plus 3i and one of the foci is at capital A 4, 0. So that means x is equal to 4, that is the straight line, parallel to y-axis or the imaginary axis, will pass through the center of the circle and the foci, one of the foci of the ellipse, capital A. Note that the line x is equal to 4 passes through the center 4 plus 3i of the circle and the focus A with coordinates 4, 0 of the ellipse E. So, how this ellipse will look like? I am not deriving that equation, that is the Cartesian equation, I am not deriving. Therefore, that it's an ellipse, I will agree. So, we take this one. So, we have the circle with center 4 plus 3i. X is equal to 4 passes through the center of the circle and also passes through one of the foci of the ellipse, that is capital A with coordinates 4, 0. Agreed. So, where is this and how is this ellipse? I am not showing or I am not drawing and I do not know. Let us say. Now, what is this complex number? That means what are the coordinates of this point? The center is 4 plus 3i. The radius is 2 units. So, walk backwards on the line x is equal to 4, 2 units. Then it will be x plus 5y. And walk backwards 2 units on x is equal to 4. You will get 4 plus i. And the above one is 4 plus 5y. Agreed. So, that means since the center of the circle is 4 plus 3i and its radius is 2, the points 4 plus I and 4 plus 5i lie on the circle. In fact, they are the end points of the one of the diameters, that is on the x is equal to 4. Agrees. Our question is, where is 4 plus I with respect to this ellipse E? Our question is, where is this point 4 plus I with respect to this ellipse? Now, take this 4 plus I, z is equal to, and substitute in mod z plus mod z minus 4 minus 6. Now, when you substitute this, after substitution, if it is equal to 0, this point will lie on the ellipse. If it is greater than 0, this point lie outside this ellipse. And if it is less than 0, then z is equal to 4 plus I lie strictly inside the ellipse E. So, now substitute mod z, mod of 4 plus I plus mod of z minus 4, mod of 4 plus I minus 4 minus 6. Mod of 4 plus I is under the square root of 4 square plus 1 square, that is root 17. 4 cancels here. Mod I is plus 1 minus 6. Square root of 17 is little more than 4, that is, let us say 4.1, something like that. It cannot be 5. So, 4 point something plus 1, it will be 5 point something minus 6, it will be negative. It is negative means what? 4 plus I, the point lies strictly less than 0, strictly inside E. So, that means a point 4 plus I of the circle lies strictly inside the ellipse E. So, imagine now what happens. This implies the circle intersects the ellipse E in 2 points because a point of the circle lies strictly inside the ellipse. That means the circle will pass through that point and that point is strictly inside that one. When it is passing, it crosses the ellipse once, and when it is leaving, it crosses again the circle. again the circle again intersects the ellipse. So the first, to reach this 4 plus I, the circle crosses the ellipse once. After passing through 4 plus I, it crosses once again the ellipse in another point. So that in total it intersects, that is, the circle intersects the ellipse E in 2 points. So that's our answer. Let's look at our options. Our answer 2 appears again next to option C. Therefore, the answer to this question is option C. So that is the detailed discussion of the solution of a problem which is related to a circle and an ellipse in the complex plane from the section complex numbers and quadratic equations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.